radiation. Okay, clear that away. Just to recap, what were the three methods of heat transfer we talked about? There is conduction, convection, and radiation. Now those are probably the three most important ways, but there are other ways that heat can be transferred, and because we're talking about global warming, I do want to mention one more now, okay? And this one is latent heat. Latent heat, and I need to really describe what this is, because later on I'll be explaining how latent heat actually affects the Earth. Actually, it results in cooling the Earth a little bit, and I need to talk about that a little bit later on. Basically, latent heat is most noticeable when objects change form. So let's say you have something which is solid, like for example ice, and then you have something which is liquid, like water, and then you have a gas, like water vapor, for example, water vapor, or we'll call it steam. So when these change state, we get a release of latent heat. It's called latent heat, yeah, because it's as if the heat is hidden. Now, when an object changes state, for example, from a solid to a liquid, we call that a phase change. Phase change. Yeah. Or it's also a phase change when a liquid turns to a gas. Now, a liquid turning to a gas, liquid to gas, for example, like water to water vapor or water to steam. This is something which is very important in the Earth's atmosphere, and we're going to be talking about this a lot. But I need to actually explain to you how this can result in a transfer of heat. I want you to imagine that you make your hand wet. So there's your hands there. There's your hand, and you put some water on your hand. There's a big drop of water on your hand, and then you shake your hand up and down. And when you shake your hand up and down, because your hand is wet, it will feel cold. And your hand feels cold because there is a phase change happening. The phase change, the liquid, the water, is changing into a gas. So the liquid is actually evaporating. Let's draw this a little bit in more detail. If there's your hand, there's the skin of your hand, and we're going to draw this water droplet, there's the water droplet on your hand, and you're moving your hand around, and the water's evaporating. Let's see what's actually happening. Inside the water, we get water molecules. Now, these water molecules, they have heat. They are vibrating. But when they move into the air, the water molecule moves into the air, it's taken that vibrational energy, that kinetic energy, it's taken it away from the water. So the actual temperature of the water goes down, and that's why your hand feels cold. In the atmosphere on planet Earth, this is a very important mechanism which transfers heat from the ground or from the sea up into the atmosphere. Let's draw the sea here. There's the sea, It's wet. Yes, and as we know, there are water molecules in the sea. Yeah? Say the wind blows across the sea, yeah? And the water molecules escape into the atmosphere. Because the water molecules have escaped into the atmosphere, the temperature, the actual temperature of the sea gets cooler. It gets a little bit cooler. Right? Now, this water now, yeah, is as a gas. Yes, it was as a liquid when it was in the sea, but now it's jumped. The water molecules have jumped into the air, right, and they've turned it into a gas. And let's say this gas, it gets warm and it rises up in the atmosphere. And as you know, as things rise up through the atmosphere, as they rise up through the troposphere, things get colder. You know, I mean, it's colder higher up, isn't it? It's colder at the top of Mount Everest than it is down at sea level. And because it gets colder, eventually this gas will turn into water droplets again. In fact, it will turn into rain. Now later on, well, I'll explain this in a little bit more detail. Right? But the water vapor, the gas, yeah, then turns back into a liquid again. Right? And when it turns into a liquid again, let's have a look actually what happens. So we have these little water molecules as a gas. Here they are as a gas, right? They then go into the rain droplets, right? So they are taking their vibrational energy, because these little molecules are vibrating, right? And they put this vibrational energy back into the water again. So therefore, the water, this actual water, then the temperature of the water gets hot, right? And because the temperature of the water gets hot, it starts to transfer this energy, this heat energy, right, to the air around the raindrop, because there's air, isn't there? There's air all around the raindrop, and it transfers this heat to the air, so the air actually gets hot, and then the air starts to radiate the heat, yes, out into space. Yeah? So, because the air is radiating this heat out into space, you know, the air has actually got hot, yes, at the top of the atmosphere. The temperature has actually gone up, yes, right, and here the temperature has gone down, so we can see that the heat has actually been transferred all the way up to the top of the atmosphere. And this is a way that heat can be transferred from the sea, yeah, and actually leave planet Earth. So we are transferring the heat, yeah, from the sea, right, out into space, okay, beyond the Earth's atmosphere. Okay, so just to recap, the actual heat, let's try and remember what heat is. The heat is the vibration of the atoms or the molecules, the vibration of the little particles within a substance. The more the molecules are vibrating, the more they're moving from side to side, the more kinetic energy they have, and this kinetic energy is the actual heat. Now, because this lesson is about global warming, the course is about global warming, we are mainly going to be talking about radiation as heat transfer, and we'll talk about that next lesson. Okay.